Hello all. Now we are going to discuss on the road lighting and the area lighting. First we will discuss what are the factors to be considered while designing a road lighting project. So the basic purpose is to provide an appropriate level of visibility to the motorist to ensure the safety in driving. It also plays an additional role of creating a more inviting and safe environment in cities. And the ability of road lighting to illuminate an object is affected by the quality of light and other physical factors such as traffic level and road surface. So that is being defined by the factor RP. So a good road lighting system will ensure visual detection of an object at greater distances. So while approaching in a vehicle, the road should be clearly lit and so that the safe driving is made possible. So that is the main function behind a good road lighting project. Now we will see the various factors. So before that, this is just two pictures. This is using a sodium vapor lamp and this is using an LED light. The same roads are being lit. And here we can see that LED is a new technology which is being utilized in many of the new projects in the street lighting. And sodium vapor lamps are being replaced by the LED lamps. So a more clear visibility and a good color rendering index is being provided by the LED lamps. So you can see the effect of both the lights in both the cases. So here it is having a good white light, but this is having an yellowish tint. So the first factor we need to consider is the road luminance. So it is a measure of how visible the road is to a motorist. And luminance is dependent on the light distribution of the luminaires, the lumen output of the lamp, installation design, and reflection properties of the road surface. So higher the luminance, higher or better the lighting, and is a 75% RP is considered sufficient in most of the road conditions. So road luminance is how visible the road is to the motorist. The next factor is uniformity. So it is the even distribution of light on the road, and it is being defined as an overall uniformity and also longitudinal uniformity. And what is meant by overall uniformity and longitudinal uniformity we will see in the next slide. So a good uniform light distribution will ensure that all the spots and objects on the road are clearly lit and visible to the motorist. So the industry accepted value of overall uniformity is 0.4. So this is just showing two pictures in view of overall uniformity. So the left side picture is having a good overall uniformity when compared to the right hand picture. So you can see that when the road is clearly lit, all the objects in that particular road should be clearly visible. So there should not be any dark spots. So you can just observe that this particular box is visible in the case of a good overall uniformity, but it may not be visible if the uniformity is lower. So an open manhole, a road excavations, sharp objects in the road, people crossing the street won't be visible if your overall uniformity is lesser. Next one we will see about the longitudinal uniformity. So longitudinal uniformity ensures comfortable driving conditions by reducing the pattern of high and low luminance levels. That is, when you are traveling on the road, if one of the street light is off or alternate street lights are off, then you will see a zebra effect. So some part is highly lit and some part is poorly lit. So a zebra effect is being laid. So this is again two pictures, and this is with a good longitudinal uniformity and this is with a less longitudinal uniformity. So here you can observe that the zebra effect, that is the dark shades which are coming on the longitudinal parts. But if a good longitudinal uniformity is there, then you will not see any zebra effect. So you will see a continuous uniformal lighting distribution throughout the load. The next factor is with the glare. Glare we have already discussed in the interior lighting. So it is nothing but a irritating sensation or a blinding sensation when the brightness of the light exceeds the adaptation level of the human eye. So it is producing a discomfort and reduces the road visibility. You can just observe a high beam light is coming to your eyes while you are driving. So that is nothing but a glare. So higher brightness of light which comes to our eyes, which exceeds the adaptation level of the human eye, is nothing but the glare. So it is measured in terms of threshold increment. There is a percentage increase in required luminance to compensate the effect of glare. That is, in order to avoid the glare, you need to compensate with an extra light. So that is being given as a factor of threshold increment. So this is just showing the two pictures of the effect of glare. You can see that the glare from the two street lights on both the images are very high. So that poses a risk to the motorist and the pedestrian who are moving under the light. Next factor is surround ratio. So the road lighting is not only for the road, it is also for the adjacent areas where pedestrians and motorists are also moving. So the periphery of the road should also be clearly lit. So this is just showing this is nothing but your roadway or the streetway. But this is the lamp. So this should be providing ample lighting to the periphery of the road so that it is easy for the motorist and also for the pedestrians to walk. So the SR is the surround ratio, which is the visibility of road's periphery relative to that of the main road itself. And it should be at least 0.5 value. Next factor is the color rendering index. So it is the measure of the ability to reproduce the color of an object. So your sunlight or the natural light source has a color rendering index of 100. It is measured on a factor of 100. The higher the index, the better is the visibility. So this is just showing three pictures. This is during the daylighting. This is during the night time with the sodium vapor lamp, which is having the least color rendering index. And this is with an LED lamp, which is having a color rendering index greater than 100. So these two pictures are more matching because it is having a good color rendering index. So the lighting scheme which you are choosing should have a good color rendering index. So earlier we were using sodium vapor lamp because it was more highly efficient. But nowadays the LED lamps are also at par with the sodium vapor lamps, and therefore it is being replaced by the LED lamps, and it also has a good color rendering index. Next we will see the various terminologies which is related to the road lighting. So this is nothing but your pole of the street lamp, and from that there is an arm is there which is projecting onto the road, and this is the lamp. So MH is indicating the mounting height. This is the pole arm, then you have the lamp. So this is nothing but your straight side. This is nothing but your straight side. And this is nothing but your pole setback. So by the distance by which the pole is set back. And the value or the point directly under the lamp is nothing but the origin. The point that is directly under the lamp is nothing but the origin. And you have this line 0 mH LRL, 0 mH TRL. So LRL is nothing but longitudinal road line, and TRL is nothing but transverse road line. So 0 mH means it is the first line which is under the origin, which is just going through that particular origin and parallel to the curve. Curve is nothing but this one. And transverse road line is imaginary line perpendicular to the curve or perpendicular to the 0 mH LRL. So this is the total road width. So origin is the point on the road directly under the luminaire. Longitudinal road line is imaginary line parallel to the curve. These are all the LRLs. In that 0 mH LRL is nothing but which is passing through the origin. Transverse rod line is perpendicular to the curve. So these are TRLs. And which whatever is passing through the origin point is 0 mH TRL. This 0 mH is indicating mH is the mounting height. Then longitudinal distance is the distance measured between the two TRL in a direction parallel to the curve. And the transverse distance is measured between the two LRL in a direction perpendicular to the curve. Now there are various arrangement of lighting system. So this is your roadway. Either you can keep your street light on one side. So this is known as a one-sided arrangement. Next is you can keep the street lights on either sides. So there are 2 times the number of lamps when compared to a single-sided arrangement. Then you will go for a 2-sided staggered arrangement. That is, you can just imagine it as a zigzag. And the other one is double davit median arrangement. That is, when the road is having a median, you are going to fix the lamps on either side of the median and the roadway are being lit. Next is double davit opposite arrangement. So you will be placing the street lamps on the median and also on the other side of the road. So the vehicular movement is indicated by these arrow marks in each of the figure. Next is double davit staggered arrangement. So in the median, both will be kept on either side, and then the other side of the rod will be at a staggered arrangement. So it will be moving like this, then this one, then this one, like that. So normally we'll be using a one-sided spacing, or sometimes in two-sided in the case of highways. That is with the general terminologies and the requirements of a good road lighting project. Thank you.